In this video I'm going to show how to use DMDE to extract data through HDDSuperClone, only not unlike the first video where I showed how to do it in the fewest steps possible. This time I'm going to go for speed on the first run, but it's going to be a multi-step process if we're to get to the end result. The whole purpose of this is to try and get as much data as we can fast in case the drive dies while we're instead of digging for it as we go. So I've already chosen the source, destination, progress log. I'm going to go straight to settings right now. I'm going to go to timer settings. I know that this drive, from trying to clone it originally, does not respond to a soft reset. It only responds to a hard reset. So I'm going to change the hard reset time to 0 so that it jumps straight to a hard reset from the soft reset. I'm going to change the soft reset time to 500 milliseconds so it doesn't even try the soft reset for until a half a second. The reason is this drive I know takes about 3 seconds for a bad read. We're going to try and shorten the time by sending a reset at a half a second so that the drive doesn't spend all the full time messing around with the bad sectors. So I'll click OK on that. I don't think we started the virtual driver, so make sure the virtual driver is running. Connect. We're going to start out in virtual mode 1. So we got mode 1 going there. And actually, you know what? We're going to start right out. Well, no, we're going to leave mode 1 to start out with because we might need it. Uncheck the slow driver. Make sure that's always unchecked before you start. For data extraction, there's only certain times when you want it checked, like if you're going to do a part probe. So, and we're going to start. As soon as our runtime is moving, we know we're running. We're going to start DMDE. Now, before I click OK, I'm going to choose the drive. Kind of important to do that first because if you accidentally click OK without choosing the correct drive, it kind of screws you up. I want parameters. I'm going to change those right now. IO errors, always ignore. I like my fill to be zeros. It's a good idea to match the cluster size of HDDSuperClone with the buffer size, which HDDSuperClone is set at 128 by default, and I didn't change it, so we're going to match it here. OK. And you see that's where I clicked OK there. If I hadn't chosen the correct drive before, it would have started without me wanting it to, which happened in the previous take of this video. So there's our partition. We're going to choose that. We're going to open the volume. And there we are. We're going to do the same thing we did before. I'm targeting the same set of picture files to recover. I can remember which ones they were. Oops, no, not the whole thing. That would be bad. Alright, so I've chosen what I want to recover. So I'm going to click on the recover. Just verify the size, 220 megabytes, okay. That's not where I want it to go. So now I know where it's going. Now I'm going to show you, remember the options. I've already set the IO parameters. We're going to verify it. Always ignore zeros, 128 buffer size. We're going to go to event handler. Remember, on failed open file, we want to skip so that it doesn't stop every time if it can't read or act. I don't know what it says. Failed open file. I think it means more that it couldn't find the file, or there was an issue with the MFT being damaged, which there's definitely some damage to MFT on this drive. Error reading file, we want to go to move to bad. Remember to set that now, so that way any bad files, any files that have errors in them get moved to there. So we're going to click OK. Back here, click. I think we're ready to go. Click OK to start. Yep, that's where I want them to go. So now it's running. So I changed my timer, but I'm still in virtual mode 1, which is spending a lot of time for each read. So I'm going to switch it to virtual mode 2. So instead of trimming and scraping each read down to bads, it's now just marking them in 128 cluster size as non-trimmed. That's going to speed up our overall process. I didn't time it the first time. Not planning on timing it this time, but this will speed up the overall read process. However, we're going to end up with our bad files having more bad sections in them, but we'll end up getting more of the good files early on. Like I said, any reason that you'd want to do this is if you're trying to get as much good data first before you start digging in the bad spots or digging too hard in the drive, in case it decides to fail on you, you at least got the most you can first. Well, like I said, I didn't time it, but that was noticeably faster. So you can see we still failed to get 2 files at all, and then 102 bad files, and those files are going to have more or larger size errors in them. I'm just curious. Let's take a look at our recovered, our bad, find a bitmap. No, it doesn't have a very big. I don't know if it had a bigger error in it. Now that one does. See, there was just a line in that, I think, before we looked at this one. Now there's a huge chunk. Instead of 1 sector, it's 128 sectors missing. So I'm just going to close right out of DMDE because I found that once I have to stop the virtual driver, or stop the process of HDDSuperClone in virtual mode, you have to restart DMDE for it to find the correct drive again and work with it. So we're just going to close that out. D was to quit. Yes. So I'm going to switch it to clone mode now. So what's going to happen is it's targeting this domain. So it's just going to focus on these non-trim sectors and get them all the way down to the number of bads. So we're going to start that. And it should jump into trimming, which it is. And I left the timeout so that this thing will go faster and get as much data as we can fast, and we'll let that go. Okay, that part of the recovery process is finished, so I'm going to click OK on that. Now I'm going to switch it back to virtual mode. I'm going to go for virtual mode 1 again, just in case this it gets asked for any more data, so that it gets whatever it can. Because in theory right now, non-tried, 0, it shouldn't ask for any more. We got 230 beds. In the last one, we had 225 beds. The reason we got 5 more beds is because I played with the timer. I made it do soft resets, so there was a few reads that it could have got data, but it didn't. But that's, you have to use a determination of how low you want to turn that timer, risking not reading some data. So anyway, I'm back to virtual mode 1. I'm going to start it. Timer's running. I'm going to go back to our recovered, and I'm going to do the unthinkable. I am going to delete our files. Wait, what? Delete our files that we recovered? Well, they're all already recovered to the image file, to the destination, so we didn't lose anything. So I'm going to start DMDE again. Pick the proper disk, change our parameters. Remember, do that right away. Always ignore IO errors. I like my fill to be 0. Match the cluster size. Now you see everything happened pretty fast there, so I'm going to choose our same partition, open the volume. See, everything's happened fast because it's reading everything from the destination now. So I'm going to go back. I'm going to target the same pictures as before. Go for recover. Remember, we're going to go into options because this is still going to report errors. We already set the out, for instance, IO handler. We want skip files that can't be opened, and move to bad files that have errors. Okay. It never remembers where I want to put things. So now, see how fast that's happening? I'm surprised that never said reading from destination. So now we say we've got same, couldn't open 2 files. It says 94 bad files, and last time it was 93. It's okay. So now if we go back to our recovered in the bed, we find that one bitmap again. You can see now it's down to the one line. That's smaller instead of that being that big black chunk. So it's a multi-step process to do it that way, but if you're worried about the drive dying, what I did there was try to get the most good data, let it get, the file, get as many files as it could first before going back and really digging for the data. And if you really wanted to do something like that, when you did a recover, you would potentially go into your options and in the event handler, instead of error, initially when you first do it, instead of changing that to move to bad, you just tell it to skip, which means as soon as it found an error, it would just skip that file. It wouldn't even try to recover it, so it wouldn't try to get the rest of it and just move on to the next file. Little things like that you can do. There's a lot of possibilities, but you see the results I got. This is an alternative way to do a recovery, and I give the explanation of why you would want to do it this way. It all depends on the scenario and what you feel you need to do. I would just like to add to this. Let's say you recovered some files. Now you decide you want to move on with cloning the whole drive. Maybe the file table is screwed up a little bit more than you liked, and you think you might want to do a raw recovery. Target what you can. So we're not going to use DMDE anymore. We'll close that. Now we're going to focus on HDDSuperClone. So we'll stop that. We'll switch back to clone mode. Now we're still stuck in this domain. If you want to then do a start cloning and get be able to clone the rest of the drive, the whole drive, and we need to clear the domain. Oh, it tells me I got to disconnect first. I'll say clear the domain. So now it's cleared. Now you can see the domain size went all the way up to the total LBA. So now if we hit connect, we are in clone mode. We'll click start. It jumped to phase 3. It does that because inherently it had ran to phase 4 to the end before. So the way to get around that, if you want to, because we only targeted a little bit of data, we want to still be able to do the head skipping. We're going to reset current status. And that will reset the current log status to phase 1, current position to 0, and reset all skip data. Yes, we want to do that. So we do that. Now we click start. It's back to phase 1, and our current position went back as far as it could to whatever data hadn't been read already. And we would let this run through its phase 1, 2, 3, 4, however far you let it run until you think you've got enough data or you've got all of it. And that's how to continue on after targeting data, continue on to actually do a full clone after the fact. I would like to point out that during this data extraction attempt, our image file here, apparently we can't see the size of it without me dragging this over. Anyway, image file says that it's 160 gigabytes. Well, we only recovered about 220 megabytes of data, and actually it was 240 total, probably with other data that was recovered necessary for it. So why does that say 160? Well, it's a sparse file, which the nice thing is because of that, if you're trying to recover, say, 10 gig worth of pictures off a 2 terabyte drive, and all you have for a destination drive is a 1 terabyte, well, you use an image file like this. And let's take a look and see. We look down here. Let's see the commands I did. First command is ls-lsh. The first L stands for list, S stands for show the actual size on disk, and the H is for human readable form. And then obviously I did the path to where this is. So you see the list, first file right here, image.dd. Up here it's 160 gig. Down here it says 150. That's because this is showing a base 1024 instead of base 1000. Here's just the interesting thing: size on disk 355 meg. So it's only 355. It's only taking up 355 megabytes of disk space, even though it says the actual size is 150 gig. If we want to go a step further, I added the --si, which puts it in base 1000. So now you can see now it says 161 gig, which matches our more of our 160 gig up here. And it says 372 megabytes is the actual size on disk. So as you can see, it's not taking up that much space, even though it says it is. So you can actually recover files to a smaller disk, even though you're using an image file, because you're not cloning the whole disk. The downside is to recovering a large amount of files is the files are going to take up the same amount of space. So really, the files in this recovered folder are taking up this 372 megabytes, and this image file is taking up 372 megabytes. So together, it's double, because you're recovering the files, plus you have an image file, you're taking up twice the space. But if you're only recovering a small amount, or even a decent amount, you still can recover using a smaller destination, as long as you don't go over. If you're going to go over, then you're going to have an issue. If you're going to try and planning on cloning the whole drive, you better make sure that you have enough disk space.